Good morning, students. Today we'll be dealing with the topic measurement. So let's begin with the definition of measurement. Measurement is defined as number of times a chosen scale is used. Then the next question arises is that why do we need to make a measurement? We need to make the measurement so that we can know the accurate value of some physical quantity. Now for measurement we require specific scale, and that scale is referred to as unit. A unit is a measure, device, or a scale in terms of which we make physical quantities measurement. The value of a physical quantity generally consists of two parts, a numerical quantity and a unit is equal to their product. For example, length can be defined as 2 meter. So 2 is the numerical quantity and m is the unit in which the length is measured. There has to be certain characteristics of a unit. The first one is that it should be relevant. The unit should be relevant to measure a particular physical quantity. It should be convenient to use, that is, it should not be too complex, and it should be well defined for measuring a particular physical quantity. Now, there were certain methods which were used by our ancestors for measurement before the discovery or before the invention of the SI units. These were the different human parts which were used for measurement. Some of these were digit, the width of a single finger, then foot, which was the length of a foot, and then cubit, length of an arm, hand span, that is the distance between the tip of the thumb and the tip of the little finger when the hand is fully stretched out. Similarly, there was another unit, fathom, which means the distance between the ends of the hands of an Anglo-Saxon farmer when his arms were fully outstretched. It is interesting to note that these are still used sometimes. Romans, they used a unit called pace, which was equal to the stride of their army contingent, and they called the distance traveled by it in 1,000 paces to be equal to 1 mile. Similarly, grain was used as a unit of mass in 16th century. Standard units were used so that there was no confusion among different countries. Let's talk about the Indian measurement systems. Indian measurement systems in the ancient period. There were excellent examples of measurement practices in different historic periods. For example, about 5,000 years ago in the Mohenjo-daro era, the size of the bricks all over the region was the same. The length, breadth, and width of bricks were always in the ratio 4:2:1, and it was taken as a standard. Similarly, around 2,400 years ago, during the Chandragupta Maurya period, there was a well-defined system of weights and measures. The smallest unit of length was 1 parmanu. Small lengths were measured in anguls. For long distance, yojan was used, and 1 yojan is roughly equal to 10 kilometers. During the period of Mughal Emperor Akbar, the gaj was used as the unit of measuring length. Each gaj was divided into 24 equal parts, and each part was called tost. The system was extensively used to measure land pieces for construction of buildings, houses, wells, gardens, and roads. Then the Indian measurement system during the British period. During this period, inch, foot, and yard were used to measure length. Then grain, ounce, pounds, etc. they were used to measure mass. The essential unit of mass used in India also included rati, masha, tola, and mon. Rati is a red seed whose mass is approximately equal to 120 milligram, and it was widely used by goldsmiths and by practitioners of traditional medicine system in India. Now let's talk about the modern measurement systems. After detailed deliberations, the basic unit of length and mass were defined and the working standards were prepared. An international treaty called the Metric Convention was signed in 1875 to follow metric system throughout the world for trade and commerce. There were two systems which were used at this time. The CGS system, which was based on centimeter, gram, and second as units for length and mass and time, while the MKS system used meter, kilogram, and second for the same. In 1958, it was realized that the units defined as standard needed to be redefined. The new exercise of redefining the system of units led to the birth of SI unit of systems, which is currently the system in use. SI units. An international system of units called SI units was adopted at the 11th General Conference on Weights and Measures in 1960. SI unit is derived from the French word which means Le Système International de Unit. The SI system of unit is based on base units corresponding to 7 base physical quantities. So these are the 7 physical quantities based upon which the SI units are used: length, mass, time, electric current, thermodynamic temperature, amount of substance, luminous intensity. And the name of SI unit for them are, for example, for the luminous intensity it is candela, for amount of substance it is mole. The SI units for all other physical quantities such as area, density, velocity can be derived in terms of the base SI units, and they are called as derived units. In order to find the derived unit for a physical quantity, we have to find out the relationship between the physical quantity and the base physical quantities. Then substitute the units of these base physical quantities to find the desired derived unit. For example, to find the SI unit of force, as you all know that force is mass into acceleration, and acceleration is nothing but change in the velocity with respect to time, and change in velocity is length upon time. So the formula for force can be written as mass into length per unit time into 1 upon time, which is equal to mass into length upon time square. So in this way we can find the SI unit of force, and this comes out to be kg, meter per second square, and this is called as a derived SI unit. These are the examples of some derived SI units. For example, the derived unit for volume is meter cube. The derived SI unit for work is kg, meter per second square. I hope the presentation was fruitful for you. Thank you.